8.2, using Python's unit test module. We're going to look at how Python's unit test tests are structured, the assertion methods we can use to check for specific conditions in our code, and how to set up an environment for tests and to clean up after them. The unit test package contains a framework for performing automated unit testing. Most of that functionality is based around the unittest.testCase class, which we'll inherit from to create our own tests. In the basic test example on the top left, we see the basic features of a test case in action: test methods and assert methods. Any methods we define in a class inheriting from test case that have names starting with the word test are assumed to be unit tests. In this example, that means the test addition method is a unit test, but if we added another method to the class called connect, the unit test module would not treat it as a unit test. A test case can contain more than one test, and should when those tests are logically related and require the same operating environment to run. Inside of our test addition method, which is a unit test, we used a method called assert_equal to actually check that the result of the code was as expected. Test case provides a wide range of these assert methods, which test for various relationships between our results and what we expected. We've already seen the assert_equal method. It checks whether two values are equal and makes the test fail if they are not. The assert_not_equal method performs the inverse operation, checking whether two values are equal and making the test fail if they are. The assert_almost_equal and assert_not_almost_equal methods are for use with floating point numbers. The way computers handle floating point numbers means that numbers which should be exactly equal actually differ in their least significant bits, at least sometimes. For example, if we square the square root of 7, the result is not exactly 7. So assert_equal will treat it as not equal. However, assert_almost_equal will recognize that the two numbers are the same for practical purposes. The assert_greater, assert_greater_equal, assert_less, and assert_less_equal methods check for the ordering relationships between their arguments. The assert_is and assert_is_not methods check whether the arguments are references to the exact same object. The assert_is_none and assert_is_not_none methods are a special case of that, and check whether the single argument is in fact the constant none. The assert_is_instance and assert_not_is_instance methods check whether the object in their first argument is an instance of the type in their second argument. The assert_in and assert_not_in methods check whether the object in their first argument is a member of the container object in their second argument. The assert_count_equal method is interesting. If we want to check whether two sequences are the same, we can just use assert_equal. But assert_count_equal is for when we want to check whether two sequences contain the same values, but don't care about the order. The method will cause a test to fail if any of the members of either sequence appears in any other sequence in a different number of times. So, if A is in the first sequence twice, it has to be in the second sequence twice as well, but we don't care where. Finally, we have assert_raises, which functions a little differently because it needs to catch the exception raised by the running code. That's a situation tailor-made for a context manager, and that's what assert_raises is. Used in a with statement, assert_raises makes the test fail if the code inside the with block does not raise the expected exception. That can seem a little backwards, but it's correct. The test fails if the expected exception is not raised. Sometimes, raising an exception is the correct behavior. For example, passing none into the int constructor should raise a type error, and if it doesn't, that's a bug. I mentioned in passing that all of the unit tests in a test case class should share the same operating environment. What does that mean? That means that each of them expects any external data that they access to be in the same state. For example, in the shared env tests on screen, each of the tests accesses a particular file, and each of them expects to find the same information inside that file. In this example, we have two tests that both read and write the same text file. Both of them expect it to contain the same specific information when they start running. In other words, both of them have the same expectations about their operating environment. When we have multiple tests that share the same expectations, and they're logically related, we should group them into a single test case. Then, we give that class a setup method, which is responsible for making sure that those shared expectations are met, and possibly a teardown method, which cleans up any changes that the setup method or the tests may have left lying around on the system. The setup method is run before each unit test in the test case. So in our example here, which has two unit tests, setup is run twice, once for each of the unit tests. Similarly, teardown runs after each unit test. That way, the changes that one test might make to the operating environment are removed before the next test runs. The starting environment is the same for each unit test in the test case. So that's the basic mechanics of Python's unit test framework as far as writing tests goes. To run the tests, we just need to invoke the unit test module from the command line. We tell it the file name of the module we want to run the test from, and it finds the test case classes in that module, creates instances of them, runs all of their tests, and gives us a report of which tests passed and which tests failed. Each test is a method of a unittest.testCase subclass. Test methods should have names that start with the word test. Test case instances have assert equal, assert almost equal, assert not equal, assert in, assert not in, and many more methods that we can use to check for whether our tests pass or fail. If a test case has a setup method, it is called before each test. Similarly, a teardown method will be called after each test. There are even easier ways to run the tests, but we'll look at that after we examine mock objects, which is the topic of the next video.